SwayamPrabha. Digital India. Educated India.
Hello, Namaste. Welcome back to the module where we are looking at how a database works, what is a database management system, etc. So, in the previous class, we learned what do we mean by a data. Then we evolved in terms of what do you mean by a database. Then looked at the database system and the database management system, which is an application. So, we have looked at all of these. Now let's get into what do you mean by a database management system, how does it works, what are the different relations that exist in this particular database management system, and how we perceive that particular relationship. We'll look at all of these in this particular lecture. And when we look at the concepts that would be covered in this particular class, first thing that I would speak about is what do you mean by a database management system components in a database management system, then characteristics of a database management system, then we define what is an entity. So now we'll also take it ahead and look at something called as an entity relationship, how entities are related, what are the different relationships that exist, and the same concepts that we were looking at the spatial aspects. So we would now put it in terms of a database. Now we would look at what do you mean by a database management system architecture. Okay, what is the architecture of a database management system? Then there are a database management system languages, a broad definition of languages. I'm not getting into very specifics, a very broad system of different languages in database management system. So when we look at the components of a database, the first and the foremost important component of a database is the database engine. When we look at this database engine, it is the heart of the database management system, responsible for storing, retrieving and updating the data. So this is like a backbone or the heart of a database management system. So this runs through the entire structure and is very important for storing, retrieving and updating the data. There is another concept called data dictionary. So dictionary, it holds definitions for all the data tables. Okay, it is like a defining key in which actually is defining all the tables, or the definition of all the tables that describe the type of a data and that are being stored in that particular database. Okay, so then we have a query processor. So when we look at these two words, query and processor, which means it is processing a query, it is basically a fundamental component which enables users and developers to store and retrieve data. Okay, it is both storing and retrieving. So when we say querying, you are actually storing some data and retrieving a data. So all these database operations can run through a query language, like a sequential query language, SQL, MySQL, very well known query languages as the MySQL. Okay, though it has evolved over a period of time, but now also MySQL is quite well known. And when the next component is report writer. So though this particular component is more or less not evolved over a period of time, but it enables us to set up a report on the screen to specify how items will be displayed or calculated. So these are normally used to generate reports. So in many systems, many database systems, they have different way of defining it, but report writer is generally to actually compile all the information and generate reports about those informations. Then we have something called as a form generator. It is an input screen that helps developers to create forms. So, or it is an input screen that helps developers to create an way of connecting into the system. Then you have an application generator. And when you look at an application generator, it is an application is this collection in terms of forms, that is number of forms that would have been generated. It is nothing but a collection of those forms and reports by the report generator. It is a final package that consists of tools and that assist developer in creating a complete package, either a developer or a user to create a complete package. Normally it is done by a developer. Okay, then you have communication and integration, which allows to share data with other machines across different communication networks. So it is based on relations, it based on addresses, it based on the way you want to query data or you want to access data, that this communication and integration works. Then the security being a very complex issue in the database, so it has many layers of security, many kinds of security that will be embedded in terms of a component in a database management system. And when you look at a database management system, always any systems, whether it is storing data or integrating data, collecting data and then storing, processing, etc., always is dependent on a model. Okay, a kind of model which actually defines how the structure is there, how it is saved, how it is retrieved, and how different systems work. So when we look at the underlying the structure of the database, always you have, as I said, is a data model. A data model is a collection. So let's be very specific here. It is a collection of conceptual tools. So it is a collection of conceptual tools that describe data. Okay, so when you are speaking about data, there are tools that can describe data, that can describe data relationships, describe data semantics. When I say semantics, these are usage of very specific in data. Okay, and how the consistency constraints are maintained. So these are very important in terms of a data model. So it is the tool which actually connects or describes all of these. Okay, that is what is called a data model. Okay, so when I say a data model, it has support for multiple data types. It can have for example, you can have MS access, text in terms of memo, numbers, date, whatever. If you used MS access, most of this can be done, whether it is qualitative, quantitative, ordinal data, whatever kind of data that you want to put in can be put in such databases. And when you look at another important aspect is that the data model actually starts from the where the data is stored as a file in the database. So either loading of the databases from different databases and processing it and application, this all thing is done using a data model. So if in a nutshell, if you have to say, this is an index for a rapid retrieval. Okay, so it is like a book. You have number of pages in a book. Each page have let's say a certain number of pages have certain chapters in a book. So it acts as an index chapter and helps in retrieving, managing and processing anything in that book is nothing but a data model. Okay, so if in a nutshell we can just say it as an index for processing, retrieving any information in that particular database is nothing but a data model. When you look at characteristics of a database management system, it consists of a query language. For example, a sequential query language. MySQL is another query language. This is a very intrinsic part of how the query is directed into the system, and that is how that system would be programmed. Then you have security, control of the data, or controlled access to the data. So that is the security forms another characteristics of a database management system. The better the security, better is the database management system. Multi-level groups, for example, census, NGA. So all of these groups can be easily accessed. So you have different groups for different access. You have different ways of accessing each of these. You have different different user groups which have different powers of accessing this data. So that's how a database management system is done. Then you have controlled update using a transaction manager. So many a times you may also see that you have to visit a particular site or visit a particular or write to a particular person in order to have some restrictions removed for access of the particular data. So that is what is called the controlled update using a transaction manager. Then you have versioning. Versioning is a very important form of the database which actually keeps a track of what has improved and how the previous errors or loopholes in the database have been corrected over a period of time. Then the last one is the backup and recovery. This forms a very important part of any database, because without backup there may be certain issues sometimes. Maybe that particular system where the entire database is cornered, or the system that is acting as a server may fail, because every thing has its own shelf life. So once its shelf life is over, it may fail. So in order to have a backup, if the systematical backup is done, if that database can automatically do it either to a cloud system or to a system that is physically there, and or it is remotely connected, so then it becomes the best part of the database. So it is a very intrinsic characteristic of a database. So always most of the database systems, management system, have their own way of backing up the data, and also the recovery of data. That's also essentially very important in terms of having a database management system. And when we look at the characteristics of database management system, we also can look at in terms of application. I have already spoke about each of these. There's application, there is form builder, a report writer, an internet application server which is actually interacting with the user and different portals. For example, if you are looking at sensors, if you are looking at Aadhaar, if you are looking at any other different portals, so it is actually it acts as a bridge between the user and that particular portal. Then you have case tools, which is looking at particular case in terms of the query handling or query processing, etc. Then the most important point of today's system is programmable APIs, so or application program interface. So this has become extremely important in terms of how do we define an API, how do we manage an API, how do we present an API. So that is also a very challenging task today. So that becomes a characteristic of a database management system. So if you have to put in what is a role of a database management system and a GIS, if you look at it, when you look at GIS task, okay, let us take it separately and let us look at it. If you look at GIS task, what is its task? The first thing is loading of a data. So when you acquire the data, then you load the data. Once you have loaded the data, you edit the data, you either edit it or analyze it. So once you have analyzed it, you can visualize it, okay, and finally you will map it. That is how the GIS task work. So the same task can be done in terms of a database management system. So this task is somewhere, for example, when you are looking at storage, database management task is first storage, indexing it, then querying it, and maintaining a security layer. So when you are integrating both of these, it is data load. So when you have a data load, you are actually looking at storage and security of both of these, then looking at editing and analysis. This is where the query part comes. And when you look at the next part, again this is where you have visualization. Again it is a part of a query and it is a part of a storage, and mapping. Once you have a mapping, both indexing and query comes into effect. And when you look at both of these, finally you also have a security layers for different types of understanding, or maybe for download, maybe for visualization. So what kind of query it may be dependent on. Not every layer would be available for download, but it can be viewed online. So similarly, when integrating both of these database management system and GIS, it would become a very extremely powerful system in terms of land management or any of those management which has spatial features that is embedded into it. And most of today's database should and must have special features in order to survive in today's context. So when we go back to some few weeks before, we even spoke about an entity, right? So when we speak about entity, it is a separate portion of the Earth's surface. Similarly, here in a database, entity can be anything. Entity can be just a particular customer. Okay, for example, if you look at the banking database, entity is just a customer. Okay, so when we define entity, entity is anything that about which a data can be stored. Okay, so if there is a lot of data that is being generated, if there is a particular task, that becomes an entity. If there is a, let's say you open an account. Okay, so your name and your address, your address, you are an entity basically, and based on you, what are the transaction, what is your age, what is your Aadhaar number, what is your PAN number. So all of these becomes your different attributes that are stored, or the data that is stored in this particular entity. Okay, so entity is nothing but is anything that about which a data is to be stored. Then it consists of certain attributes which may be assigned certain values, as I said, your UID number, your PAN number, all these are attributes to that entity. Then entity is represented in a form of a rectangle in terms of a database. For example, I'm trying to represent a entity of a customer. So entity customer is saved in a form of a rectangle. Now when we are trying to look at the relationship, the ER model, so when I say relation, is any association, linkages or connections between the entities of interest. Now let us say there is a person who has an account in bank 1 and has an account in bank 2. Now maybe that UID number or Aadhaar number is a linkage for both of these banks. Okay, PAN number also can link both of these banks, and that link can be said in terms of relation. Person A has account in this particular bank and also has account in the other bank. So this becomes an relation between the two entities, two banks, where the customer is the entity and that particular entity has two accounts in two different banks. It is two directional, normally significant association between two entities or between entities and itself. Okay, and itself. So you should be very careful when we are representing it here. Normally relationships is represented in the form of a diamond. So the entity is in the form of a rectangle, whereas relationship is in the form of a diamond. Okay, so when we look at the entity relationship diagram, this is how normally an example of an entity relationship. For example, the student is an entity here, is a relationship, and student ID is again an entity. Okay, so student is maybe any student's name, he has a particular student ID is what we mean. Okay, so relationship is defined in the form of a diamond, whereas the entities are in the form of a rectangle. Okay, so this is how an entity relationship is built and entity relationship diagram is developed. And when we look at the types of entity, we have 1:1 relationship, which means there is one particular entity and one particular relation that is being defined. You have 1:many. For example, there is a particular class, a course. Okay, let's say GIS is a course, is being held in this particular classes. Okay, which means to say that you may have many classes, okay, many sessions, many modules, but this particular course is a single course. Okay, so it is one entity with many relationship, with many entities. Now you have many to many also, you have multiple students taking a multiple courses. So that means that it is many students has many different courses or have considered many different courses. So this becomes three different types of relationship. So the first kind of relationship is 1:1 relationship, which is actually saying that there is one entity, one relation is related to the other entity. Okay, whereas 1:many is defined between one entity and many entities, a relationship that connects. Then you have many to many relationship, where you have many entities and many entities that are related through various means. So that's about the types of relationship that exist. So as I said, database language, there are various ways of representing database languages, but when you broadly define the database languages, database systems provide two different types of languages. So the one is the data definition language. It specifies database schema by a set of definitions. Okay, for example, creating a table in the database is the way of defining a particular database, how the particular table is being created. So that is a data definition language. We have data manipulation language, which can be used for manipulation such as data retrieval, insertion, deletion, all of these, or even quantification and providing qualitative information. All of these are data manipulations. So this is handled by the data manipulation language. Okay, so when I say language, it has a series of syntax and semantics associated with it. That's why it's called a language. So we have a data definition language, we have a data manipulation language. Okay, so both of these languages together becomes a count of a database language. Okay, so the next thing that we would look at is a database management system architecture. So when we look at database management system architecture, we look at this as a 3-tier system. Okay, when we look at the architecture, the very important aspect of defining this 3-scheme architecture is to separate the user application with the physical databases. So you have user application itself is different, whereas your physical application interface itself is completely different, or the database is completely different. So you have to separate both of these. That's why a 3-tier schema is always used in terms of a DBMS architecture. Though it has evolved over a period of time, today you can find more complex schemas that are available in terms of defining the architecture of a database management system. But when we speak about a basic schema, this how the database management system architecture is defined. The first one is the internal schema. When we look at the internal schema, this describes the physical storage structure of the database, that is, complete details of a data storage access path of a database. So this actually says that where the physical storage has been done, okay, which part of the system where physically the entire data is stored, okay, and what is the structure of that particular database. Okay, it also tells you how to access these different data that have been stored in different paths in terms of path storage or to the database. So how do we access, how do it is stored, and where it is stored. So all of these are provided in the internal schema. Okay, when we look at the next part of the 3-tier system, it is called as a conceptual schema. Conceptual schema describes the structure of the whole database for a community of users. It hides physical storage structures and describes the entities, data types, and relationships and constraints. For example, if you go into a website, it doesn't give you what are different ways of your data has been stored, where it has been stored, what are the kinds of data that is available, but it gives you a lot of drop down menus maybe, or pick in boxes, so wherein you just select some of these and use it for your analysis. So that is nothing but your conceptual schema, where you don't know how the physical storage has been done, but you only know what are the different data are available, how do you access it, what are the querying mechanism, and how do you use such data. Then the third one you have is the external schema. External schema, this describes a part of a database that a particular user is interested in or particular user needs to understand, and includes number of external views or user views. And when you look at the external schema, this is the schema that can be defined based on the user base and can be interacted in terms of how the user needs it to be manipulated or maybe even modified. So once you have understood what is the architecture, the next thing that comes here is an attribute. So whenever we look at any database, so you have an attribute as a very important factor that is defining the entire database. Otherwise, you do not have a database that is existent. If you just have a customer name in the entire database, it's rather than called a ledger than a database. Database should always have an attribute information. When I say attribute information, this can be any detail. It depends on what kind of system, what kind of user, what kind of instance you are trying to use a particular database. So it can be any detail that serves to identify, qualify, quantify, or classify or express the state of entity. So, entity is a very important aspect. So, when it can be on and off, it may be colors, it may be your different types. So, all of these are defining the identity, quality, classify, quantify it. So, all of these of an entity that can be expressed occurring in terms of a relationship, that is nothing but an attribute. Attribute and entity are always connected through a relationship, and this relationship is defined based on what kind of information that entity is providing, okay, or different entities are providing. Then when you look at this, attribute is represented using an oval basically. For example, when we look at it here, where as I previously said, the rectangle is representation of an entity. Now, entity is a customer. Now, customer has an address, customer has a customer ID, customer has a customer name. Customer can have Aadhaar number, PAN number. Customer can also have different details that is required for like an maybe an address, alternate address, the mobile phone number, which is a very important part. And your and where the branch is located. So, all of this information are attribute informations. So, this this is what is another part of a database management system. So, we have three kinds of boxes. One is rectangle, other one is a diamond, other one is a oval. So, oval represents attributes, rectangle is represented by for an entity, and whereas relationships are defined based on your diamond boxes. So, in order to summarize this particular class, we first look at the components of a database. We clearly define what are different components of the database, though this has been previously discussed, but we looked at what are the different components of a database and how it can be of use to us. Then we looked at what are characteristics of a database. Characteristics is extremely important for any database management system to be understood. If you have not understood what are the characteristics of a database management system, what type of database management system and what is its characteristics, then probably implementation of a complex database managing capability may not be there. So, looking at that, the characteristics is extremely important. And when we look at the next, we looked at the entity relationship model. We did define the entity as a sole model, which is actually defining any of those information in the data, or which has data which is connected with data. That's nothing but an entity. Entity is normally represented in the form of a rectangular boxes, whereas relationship is the one that actually defines and defines or connects an entity to different attributes or different entities or different ways of maintaining the database. So, that is nothing but a relationship. So, it is normally in the form of a diamond box, and this is nothing but a ER model. And when we look at the database languages, we said that broadly it can be classified into two. One is the data definition language, other one is the data manipulation language. So, we also looked at the database architecture. What is the architecture of a database? We also looked at GIS and a database, how different parts, how a GIS and a database management system works. We looked at how if we take a GIS, how the loading of the data, how the data is then converted into different features, how the query is done, and finally you have processed information. Similarly, when you look at database management system, this particular system works, including the security, and when we combine both of these, this can become a powerful engine in terms of any applications. So, then we looked at finally at attributes. Attributes are again the part of a database that we maintain. Every database has major attributes. So, when we look at attributes, it can be anything that is linked to the entity, and most of these attributes are located in represented in the form of oval. So, this is what we have learned in this particular class. So, in the next class we will continue this understanding and we will go further. Probably I will also introduce to terms called as normalization, etc. So, which is of extreme importance. So, we will look all those more concepts about what do you mean by a database management system, what is a database, different types of a database in the next class. So, till then, have a nice time. Thank you.